objects that are getting created. Okay.
Okay. This PCH
PCH and then the shape of the point on the change basically. Point character, it stands for point character. When I come to the plotting part of it, I will tell you. Now leave that as it is. Go to the rest of the code where we have already looked at.
Okay, figure margin too large.
Adu vanda, and just leave that plot as of now. We will look at it when we come to that. First, let us understand the algorithms, how it is working. Then understanding those things will be easier basically. Okay. Dummy 1 is created, dummy 2.
Created, create a new data sets. Okay. Here price, all these someone model, transmission, fuel type. So 38 columns. Structure or final should be all numeric. Okay. Now splitting the data into train and test. Okay. Variable. Omitted 6,000 or the tree.
It's fine. In the console, when there is no space, omission is fine.
Okay, you already find a test view test. 3038 columns. Create linear regression model. What it is doing. Intercept. Make a prediction for each x. Test minus 2. Be misleading.
Okay, warning that is fine. I also got that warning, so that is not an issue. When we are looking at the correlation, also correlation is what is the thing it is giving? Supply both
x and y or matrix.
கொஞ்சம் மேல போங்க. இல்ல இதுல console just go up. What it is doing, I want to observe correlation. Okay, relation between MPG column benchmarkங்கிறது அது ஒரு நிமிஷம். I think we didn't change anything. No, why is it finding the correlation between MPG column benchmark and the predicted column? Okay, supply both x and y
or matrix like x.
Just go back. It's doing the prediction there basically.
Oh.
ஒரு நிமிஷம் அந்த அந்த ப்ரெடிக்ஷன் லைன்ல கொண்டு வாங்க ஒரு நிமிஷம். Just run the model once again, LM model. Just run that once and then give me the model, what it is giving you on the console. Just open the console. Okay, this is fine. Just get back and make the prediction there. Test -2. ஒரு நிமிஷம் அந்த டெஸ்ட் இதுல இங்க டபுள் கிளிக் பண்ணுங்க. Just double click on this. So second column is only price basically. So we are removing the price correctly. Get back to the code. That is fine. Run பண்ணுவதா. And then get the predicted. And then just show me the console now. With the values of the predicted console key. Down the console, show me those values. Okay, and it is showing us the values. Next, go to the code back. Run this line number 65 now. Line number 65 run பண்ணனும் first. Now you run 68. Okay. See, basically that column was not there inside test. Basically 65 run பண்ணாதிக்கே we are going to 68 basically. So since that column is not there, it is asking us to give X and Y basically. So if you say test price is taken as X and test predicted is taken as the Y basically. கரெக்ட்டா? நீங்க வந்து அந்த இந்த 65 ரன் பண்ணலாம் basically.
Correct. All right. Yes, நான் இங்க பார்க்கறேன் ஹிஸ்டரியில. Yes, இப்பதான் ரன் பண்ணிருக்கேன்.
ஆமா, நான் சொன்ன அப்புறம் நீங்க ரன் பண்ணிருக்கீங்க. So what has happened is now only the column got into the data set. So then the correlation is able to pick up those two columns now basically. Previously it gave you that error because one of the columns was not there basically.
Yeah, this test predicted illa adha.
Test predicted was not there, that column.
Test price. Test price. Okay. Tested all price.
Can you tell me what is the other way you would have solved if we are not entering that predicted into the test column? How would you actually compare those two columns? In this case, I am pushing it into that data set of test and then comparing those two columns. If I am not doing that, how would you do it? How can we do it now?
We mean the test dollar predicted, right?
Yeah, the test dollar predicted I'm not taking. For example, I'm not pushing it into that data set, but I still want to find the correlation between whatever we have predicted and the test dollar price column basically. What is the other way in which you would be able to do this?
Directly I can give predicted, right? Instead of test dollar predicted.
Correct.
Yeah.
Correct. So you can directly give predicted also, but here I am pushing it into the test data set so that that data will be available with us even after
something happens. We can always get back from predicted. We don't need to run the model again.
Yeah, that object will be there in our environment, so we can pull it out of that place basically. That is the idea.
Yeah, correct. Yes. Okay, so இந்த இதுதான் எனக்கு புரியல. This one why do we?
R square. I told you R square, no?
Correct.
Correlation will always be R. R square is the adjusted R square that you would find basically.
Okay.
நீங்க வந்து என்ன ஹோஸ்ட் பண்ணி திரும்பி ஹோஸ்ட் பண்றதுக்கு திரும்பி எல்லா செட்டிங்ஸும் மாத்தணுமா இல்ல
இல்ல ஐ திங்க் நான் செட் பண்ணிட்டேன்னு நினைக்கிறேன். I think I've already set this, the privacy. இங்க பாருங்க, I've already set the privacy.
இல்ல நான் கேக்குறது என்னன்னா, இப்போ வந்து if you give me the host and I share the screen and then you are supposed to share it back, whether it will happen.
I don't know, we have to test it. But I know where to go and navigate.
Okay, fine. Then not a problem. Just make me the host. I will show you the difference between R and R square.
Okay. Okay. So now I will make host. Okay. I have made you host.
ரொம்ப இறுக்கமா இருக்கு. வெளியில ஆனா மழை பெய்யறது, உள்ள இறுக்கமா இருக்கு. Okay. Saying at the right file.
No.
Are you able to see my screen now? Are you able to see my screen?
Yes, I can see.
Yeah. See the difference between R and R square. Basically, R is known as a correlation coefficient that we are getting, and R square is also known as a constant of determination, where we are seeing how well the data fits the given equation out there. Basically, that is the difference between the two. So there is a linear correlation in the thick of the two uncertain quantities that we are estimating there by extending the portion of vitality of these two quantities. So R is giving us that whether there is a linear correlation or not, and in R square there are multiple uncertain quantities which are also estimated by the efficiency of association within the thick of the multiple uncertainty out there. So what we are trying to do is within that two coefficients that we are checking, internally also we are trying to see whether there are certain repeating values which are going to be taken as set of classes, and then we are determining basically.
Okay.
And then, so the R square value will always reduce because it is taking multiple constraints there to make the comparison. Here it is only taking the column values to compare in R. So the R will be slightly higher while the R square will be slightly lower basically.
Okay.
But if I draw the conclusion there, you can see that R will be an absolute correlation if it is equal to 1, and 0 if it is, it will not have any correlation if it is 0. So it is a value between 0 and 1 there. So R square now additionally ranges from 0 to 1, which will denote 0 a poor indicator and 1 as an excellent indicator there. Basically, line fit is what you are talking when we are talking in terms of the R square basically.
Okay.
When we are talking in terms of R square, we are talking whether whatever equation we found is actually fitting the data or not basically. So higher the value of R and R square, there is the performance is better in case of the linear regression basically. That is the understanding that we should have.
Okay. Okay. So basically, the kind of robustness.
Yeah.
Okay. Indication of robustness of the linear equation that predicts the value of one variable as operator of one or more uncertain quantities.
In this case, we are taking only two variables basically, correct?
We are taking only price, Dana, Nagesh?
Whatever is the price, correct. The predicted value of price and the price column is what we are taking in the R square basically.
Okay. So the price column, which is, okay, yeah, the price and the predicted column of the price.
Correct. We are treating whatever is given in the original data set as a benchmark, and we are comparing whether the predicted is actually is it comparing well with the benchmark or not, basically.
So benchmark in this case is test dollar price.
Yeah, test dollar price is our benchmark column.
Okay, so that's where we did the testing. We got an output, and then now we are also predicting, comparing these two, which one is giving me an robustness with the R square.
Yeah, with R square, which is giving me the higher this thing. Whether it is giving me a higher level of robustness or not, basically.
Okay. If na and the correlation first line 74 matu run panna, the system does not compare price with the predicted, correct?
It compares price with the predicted, but it will be predicting all the values together.
Oh, okay.
Second case, R square it will go and use that formula 1 by n, this formula that we have looked at previously. Let me show you that formula.
Yeah, please. நாளைக்கு முடியுமா ஒரு 1 hour வச்சுக்கலாமா 7:30 to 8:30
ஈவினிங் வச்சுக்கலாமா
ஓகே அட்லீஸ்ட் இன்னொரு மாடல் ஆது we can see and then maybe next week
yeah afternoon I was actually trying to jot down the time frame basically to look at how long is it going to take na complete adu mudikka mudiyala so let me fasten up the process a little bit so that in a given day at least about 1 or 2 algorithms if we look then it will be a little faster basically. Okay. So this is the formula we are going to use there. R square is equal to 1 by n. 1 by n is the total number of observations. In our case, the observation is 10,660, whatever is there in the Audi data set basically.
Yes. Yeah.
Multiplied by the summation of xi minus x. Our xi minus x is nothing but the
predicted
price
minus
column.
Price.
Price column moda individual values minus the mean of that column.
Okay. Yeah, x value. Okay.
Multiplied by predicted columns xi, that is the individual value of xi minus the mean of that column.
Mean of the prediction.
Mean of the prediction column basically.
Okay.
the whole thing divided by the standard deviation of price column multiplied by the price the standard deviation of price predicted.
Okay, understood. Yeah. Okay.
And then you square that, and then you get that particular value there.
Okay. Yeah. This we have seen. So basically now algorithm is doing for us. That's it.
Yeah, algorithm is actually using those formulas and directly giving you the output.
Yes.
Here I told you how exactly the calculation is happening basically. And then in this case, we said it was 0.48. Correct. So what did we say? That there is some variation in our prediction basically. There is a 52% accuracy while there is a 48% deviation basically. That is what this is indicating. Correct?
Yes.
So this is what it is trying to tell us actually. 0 is indicating that there is a poor indication of that model or fit of that line basically. Whether that equation that you have done for the line fit is actually fitting properly or not.
Okay.
So 0.40 is actually closer to 0 basically. But then in our case, since the sample size there is very small, we are considering that to be an okay type of model basically. In our case, in the ODI case, we don't have a consolation on the number of data points there.
Okay. Yeah.
We already have 10,600 records there, basically.
Yes.
So we don't have a consolation on that. So the value that is closer to 0 indicates that there is an excellent performance that we have, or the equation has correctly fitted into the data basically. That is what R square is indicating.
Okay. Yes. Understood. Yep. Makes sense.
So
ஆனா இப்போ எனக்கு என்ன क्वेश्चनனா இப்போ நம்ம இந்த லீனியர் மாடல்ல we do the R square?
Yes, we have done.
Okay,
R square பண்ணதுக்கு வெளியில வர முடியாது லீனியர்ல. கோரிலேஷன் R square ரெண்டும் பண்ணிட்டு தான் வெளியில வரணும். இந்த ரெண்டு இது பண்ணிட்டு தான் வெளியில வரணும் லீனியர்ல. 1 minute, let me open that file also for you basically.
LMல அகிகா பண்ணோம், VIF பண்ணோம்.
இதுவும் பண்ணிருக்கோம். I will just show you. Wait.
Develop the linear model போயிட்டு நம்ம ஸ்டெப் AIC போயிட்டோம். அப்புறம் ஆமா
our programs
test one
ஓபன் ஆக மாட்டேங்கிறதுதா இப்பதான் ஓபன் ஆகுது.
Yes, you are right. I'm sorry. So add a new column. பண்ணிருக்கோம் நம்ம டெஸ்ட் MPGல R square பண்ணிருக்கோம். எஸ், கார்லேஷன்
பண்ணாது. இது R square பண்ணாதுக்கு லீனியர் முடிக்கவே முடியாது ஆக்சுவலா.
இல்ல you know but you have a lot of experience. எனக்கு ஸ்ட்ரைக் ஆல. Okay, clear.
இல்ல it is, you see, it's welcome because at least in the learning process at some point you have to learn it. You see, questions are always welcome. Even if you are retracing back, it is good for me basically.
எனக்கு வந்து இப்போ இந்த டேட்டா மாடல் மெட்ரிக்ஸ் நல்லா தெரியும். Then the test and train, yes, and then the correlation தான் now I'm focusing. Okay, that is very clear now. Test okay, test underscore MPG ஆமா R square பண்ணோம். Then okay, yes.
Here after fitting the model we are basically okay. இந்த ஃபைல்ல அது இல்ல. ஓகே, என்னோட ஃபைல்ல
நான் காமிக்கிறேன் வேணா. அந்த டெஸ்ட் 1ல நம்ம பண்ணி கடைசி predict பண்ணதுக்கு அப்புறம்
predict பண்ணிருக்கோம். I do remember because I have made you do that. No, I remember that. Not to worry. Okay, so So this is how you could do a regression with the SVM basically. Correct?
Correct. But ஆனா நம்ம ஏன் வந்து SVM classification சொல்றோம் but linear prediction சொல்றோம் now? Even SVM also now we are following linear model, right?
See, there are two functionalities of the SM basically.
Okay.
See, நம்ம வந்து C ல கோட் எழுதுறச்ச எல்லாம் function define பண்றச்ச எல்லாம் if I say for example let me say function name and then you say one argument in one function, correct?
Okay.
Second function I'm defining with the same name, but I'm putting two arguments, for example. What will happen? Say, for example, I have a function name.
Okay.
And I'm sorry, forgetting to give the size. Okay. And then say this is parameter 1 there, which we are passing into the function.
Okay.
Again, I'm defining another function with the same name, but the parameter is say 1 comma parameter 2. It will still work, no? C ல work ஆகும் இல்லையா? This is called as function overloading basically. C and C++ it will work. Correct? So இப்போ நம்ம என்ன பண்ணிருக்கோம்னா SVM character column if we are giving, this is functioning as a classification.
Okay.
Taking the factor as a benchmark to classify. Fine.
Okay.
இப்போ வந்து iris data set use பண்ணோம் நேத்திக்கு. Sentosa was a character column basically, correct?
Yes.
And we had 3 factor levels there. That means it will go and classify into 3 classes basically in this case.
Okay, understood. Okay.
And then when we are coming to the other one, here it is we are giving a numeric column. So basically what is happening is there is a function overload that is happening. So when it looks at a numeric column there to be predicted, it goes into the regression mode of SVM algorithm.
Okay. Okay. SVM algorithm. Okay. Prediction model. Because okay, the difference is between character versus numeric. The prediction we cannot
ரெண்டு ஃபங்க்ஷன் டிஃபைன் பண்ணிருக்காவா அந்த SVM குள்ள. ஒன்னு வந்து character column it is taking as a parameter, the other one is taking numeric as a parameter basically.
Okay. Okay. So here in this case today what we saw is the SVM regression, which is a prediction. The independent variable is a price, which is a numeric column. And yesterday what we saw is the typical that Sentosa, the character column.
Character column, which is
classification algorithm.
Correct.
Okay, okay, okay.
Going forward, you will see even in the decision tree, we will have a classification and regression algorithm internally built there in the decision tree. Even in the random forest, we will have the same, basically.
Got it. Understood. Understood. So it depends upon the business scenario or use case, we have to determine which, based on the target column, we have to determine which algorithm I have to use, right?
See, basically first demarcation என்ன பண்ணணும்னா classificationக்கு whether we are having a by class classification. What do we mean by a by class classification? A binary classification.
Okay.
Which is our 0 and 1 basically.
Okay.
So when this is there, the lowest algorithm or the best algorithm for a binary is always logistic.
Okay.
Okay. Now say I applied logistic on a given data set basically for a classification algorithm and I get a particular level of accuracy. Say the accuracy I'm getting when I apply a logistic regression say is about close to 19 vechupom in an example. But the client has asked me that I want 95% precision, for example.
Okay.
In this case, logistic is not giving me that 95%. I cannot go and modify the data and say it is giving 95 basically. I cannot do that. So what we will do is we will go and apply. Next stage is the SVM regressor.
Okay.
Even though it is a by class, all the classification algorithms will also work as a regressor, not only for by class but also multi-class.
Okay.
But logistic will not work for multi-class basically. It will work only for the binary classification.
Okay.
The other way is not true. So the same problem I will solve by SVM regressor and say I get about 92 by the regressor, SVM regressor, for example. Correct?
Correct.
Now this is still not reached my client's expectation. So I will go and apply say a decision tree regressor.
Okay.
So somewhere 94 varudanu vechukonga. I will go and apply the random forest regressor. Idhula vandu say it is giving me only say 94.5 for example. Idhiliyum varalennaka then I will go and apply a what is that multi-layer perceptron neural network, which is the simplest network out there. Most problems which are not being solved by the regressor will be solved by the MLP classifier basically. But this you are using the you will be using the ANN or the artificial neural network basically, and then you will select the method regression there internally. Are you getting it?
Yes.
And then let me say that this is coming to 96 for example. Now I will go and select these two algorithms basically and then give this to the client, because these are two things that are mapping to his requirement. The others are not mapping to his requirement basically.
Okay. Okay.
So in every case, you have to keep trying each of those algorithms, pick up the best algorithm with the highest accuracy basically.
Okay.
Your highest R square basically, since it is a regressor, the highest R square is what you have to pick up basically, and then give that model to the client.
Okay, understood.
Now it gives you some idea basically, I think.
Yes, yes.
You know,
yes.
I think you are not able to visualize what exactly we are trying to do by learning this algorithms. Am I right?
No, இப்போ எனக்கு இல்ல I got it. See, now I'm thinking on binary classifier versus multi-classifier.
Correct.
The
Multi-class.
examples. That's
See,
what I'm trying.
See, logistic one, the 0, 1 we did in the credit data set, basically.
Yes.
Defaulter status 0 and 1 was a by class.
Correct. Either 0 or 1. Correct.
Either 0 or 1 is a by class or a binary class, where there is only 2 classes to classify.
Yes.
Iris becomes a multi-class problem because it is more than 2.
Yes, we saw the versicolor and other two more.
Yeah, Sentosa, versicolor, and Virginica.
Virginica. Yes, that is.
Those are the 3 classes that are there. That becomes a multi-class basically.
Yes. So, நீங்க சொன்ன மாதிரி logistics works for a binary classifier, right? Then the multi-class will not.
I'm sorry. I think I made a mistake to you. See, இங்க வந்து by class classification நான் பேசிட்டு I'm talking about a regressor at the bottom. Correct?
Correct.
I have made a mistake. I will tell you what is the mistake. You should not be using a regressor method in the classification. You should be using a decision tree SVM classifier or a decision tree classifier or a forest classifier there, basically.
Yeah, because this is a binary. What today we saw is a binary, right? Because it's either price or predicted.
No. Today what we saw was not actually classification problem. It is a regression problem. இங்க வந்து நம்ம லீனியர் ரிக்ரெஷன் தான் போட்டுருக்கோம், லாஜிஸ்டிக் போடல.
கரெக்ட். எல்லாம் ஆமா because
எல்லாம் போட்டுருக்கோம். கரெக்ட்டா, நீங்க சொன்னது கரெக்ட்டா. We have used LM, which is actually linear regression. So on the linear regressionல வந்த output was about R square was about 88% basically. Correct? So now client is wanting 95 basically.
Okay.
So 88 வந்திருக்கு linearல. So I will go for an SVM regressor, see how much more I am getting basically. Decision tree ல எத்தனை வருது, random forest ல எத்தனை வருது. So whichever is coming maximum, I will pick up that algorithm and give it to him basically.
Okay, understood. So which means that the decision tree or SVM support vector machine எல்லாமே வந்து binary classifier, correctா?
It will support binary and multi-class.
Multi-class, okay, understood.
See, logistic only is binary.
Okay.
Rest of them will support binary class also and multi-class also.
Okay, understood, Nagesh. Yeah, this is one. Okay.
Okay.
And linear is also binary, correct?
Linear is not binary, no. You are each this thing is a different price, no. Actually, each
I'm not classifying. Yeah,
you are not classifying. You see here, actually, when we do predicted here. Okay, என்னோட இதுல இன்னும் அது இதுவே வரல. Over. See, you are predicting the price of each of these basically.
Yes.
See here, when I say this is indices, இதுக்கு முன்னாடி predict பண்ணோம் இல்லையா ஒரு இடத்துல, intercept predicted. Here you see here in the predicted. See, the second value I predicted was 20,413. This one is again a predicted value. This is the predicted value. All this is a value I am predicting for each one of those records basically. That is there in the test basically. These line numbers that are there at the top are there in the test.
Okay.
Rest of the line. See, rest of the line that is there in the missing lines are there in the train basically.
Okay.
Correct? The
Yeah.
missing lines are there in the train. So testல இருக்கிற ஒரு வேல்யூக்கும் நம்ம வந்து ஒரு புது prediction கொடுக்கிறோம் actually. So this is not binary class. This is for each value we are making a prediction basically. Prediction and classification you should not confuse yourself.
Okay. Okay. Yeah. Okay. Okay.
Just give me a minute. Huh?
Yeah. Yeah. Prediction classification.
Hello, sir. ಗೊತ್ತು ನಾನು ಒಂದು 5 minutes ಅಲ್ಲಿ ಕಾಲ್ ಮಾಡ್ತೀನಿ, ಒಂದು ಸೆಷನ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ. I will call you back. Okay.
Understood, Nagesh.
Yeah. So you should not confuse yourself between prediction and classification. These are two different things that we are doing basically.
Okay.
So you can just try this. Maybe tomorrow 7:30. Nalagi Monday.
Yeah, பாருங்க, if it is not, then maybe next week, I mean the following week Friday கூட வச்சுக்கலாம். உங்க Saturday morning எனக்கு Friday night. Otherwise it's fine. So
say tomorrow morning basically then. Correct? Am I
yes,
right?
tomorrow morning. என்னோட டைம் மார்னிங்.
உங்களோட டைம் மார்னிங்னா எனக்கு ஈவினிங் அப்பனா.
ஆமா.
7:30. 8 o'clock is fine.
Yeah, 8 is fine. So 8 to 9 வச்சுக்கலாம்.
8 to 9 இது பண்றேன். அப்புறம் I will send you the link, basically same link only, but the timing மாறுறதுனால I will have to go and change the timing.
Okay, so 8 my time.
8
ஆமா, இன்னைக்கு 7:30க்கு மீட் பண்ணோம், which is 6 for you. 6:30 உங்க டைம் Monday evening.
6:30 my time நாளைக்கு.
ஆமா, என் டைம் 8ன்னு சொன்னோம்.
உங்க டைம் 8னாக்கா difficult because I have a batch running up to 7:15 there. So 7:30 we could meet.
7:30 your time.
Yeah, 7:30 my time in the evening tomorrow, which may be or 8 o'clock my time, which will be about if I'm not mistaken 6:30 or 7 for you in the morning there. Correct?
இல்ல இப்போ இன்னைக்கு 7:30 ஏன் டைம்னா உங்க டைம் ஈவினிங் 6 o'clock. கரெக்டா?
கரெக்ட்.
ஸோ எனக்கு உங்களுக்கு நீங்க 8 o'clock வரணும்னா எனக்கு 9:30 காத்தால மண்டே.
That will be difficult for you. Already your office meetings might have started by that time.
Yeah. So I can adjust from 9:30 to 10:30. Tomorrow is fine. At least we will finish one more algorithm. That should be okay. 8 o'clock your time evening. So 9:30 my time. We can still have it, no, Nagesh. That's fine.
Yeah. I understand. Yeah, we can have. Not a problem.
Okay. So tomorrow 9:30 my time. Which is...
If it is my time somewhere at say 2 p.m. my time afternoon na உங்களுக்கு ரொம்ப early ஆயிடுமோன்னா.
அது midnight எனக்கு. 3:30 midnight. ஆமா. 3:30 midnight.
Or shall we have tomorrow morning my time by around say my time 7 is fine for you. 7 a.m. my time tomorrow morning. Evening it should be around 6:30 for you.
இல்ல, நீங்க 7னா எனக்கு 8:30. இன்னைக்கு நைட் சண்டே நைட் 8:30. 8:30 to 9:30. ஓகே நான் இது மெசேஜ் பண்றேன். that should also be okay. இன்னைக்கே முடிச்சிடலாம், நாளைக்கு வேண்டாம்.
அதான் சொல்றேன். Moment I start the day, I will start with your class. Even when another half an hour we could extend also, basically.
Sure. I think
or you have some other commitments because it is a Sunday, you need to go out or something like that, or is it dinner time or something like that?
நான் யோசிக்கிறேன், but I think I will let you know. Shall I let you know?
Yeah,
Next couple of hours நான் சொல்றேன்.
okay. Even 6 a.m. is fine with me, but you will have to tell me before so that I will try to adjust my sleep. I usually sleep by 2 a.m. So if you tell me 6 a.m., then I will go to bed a little early and then get up.
Okay, 6 a.m.
6 a.m. my time should be about
7:30 for me.
7:30 your time. So 7:30 to, I think that is again very odd for you for the dinner time, because I remember last time you were telling me about 8 o'clock you have your dinner, correct?
Yeah,
if I'm not mistaken.
Yeah, otherwise then we have to meet at 8:30 to 9:30, which is 7 o'clock morning for you.
Yeah, 7 is
7
fine
to
with
8.
me. 6 is also fine with me. I don't mind that. As you said, maybe tomorrow evening we will meet by. I will connect by 7:30 my time.
Okay, 7:30, which is 9 o'clock. Okay.
Maybe no, before that also it's slightly problematic for you. Okay.
இல்ல 9:30 to 10:30 வச்சுக்கலாம் நாளைக்கு Monday, which is Monday evening 8 o'clock for you. Is it fine?
Yeah, Monday evening 8 is fine with me.
Okay, nice. Yeah. Then I will join Monday evening 8 o'clock. Your time.
சரி, நான் அதுக்கு லிங்க் அனுப்பிச்சு விடுறேன் நாளைக்கு காலையில.
சரி, okay.
Okay then.
Thank you,
Venkatesh. Sorry for all the
connectivity. No. That's fine. It happens, but now glad we are able to identify and do something productive.
Correct. Okay, then we'll meet tomorrow then.
Sure. Take care. Thank you.
Take care. Have a nice day. Bye.
Yeah, sure. Bye.
Yeah.